Good day, everyone. Can you all hear me? Good day, everyone. Please respond if you can hear me.
Yes.
Yes,
Okay, thank you. All right, thank you. You're all welcome to the second day of this training. We had a class yesterday. A few persons were around, uh, and we did a little thing. Although I have the recordings, I initially wanted posting it today, but I was quite busy, so I could not do that. But hopefully, I'll do that after the class today. All right, or very early tomorrow, because this class is also on record. Because some persons reached out to me and told me they would not be able to make it due to the time difference or one issue or the other. So I'm taking out time to also record the class. So hopefully at the end of the day, I would post it on the group so they can also benefit from what is happening here. All right, straight to business. Yesterday we did some introduction about on robotics and the rest, and we started programming uh, the obstacle avoiding robot. Although we started it bit by bit because we can't just rush or dive into the whole system, right? So we broke it down. We started from how to blink LEDs, right? LEDs simply means light emitting diodes. So we started from blinking LEDs, and hopefully today we are meant to move into something else. All right, the sensor we are expecting to work on, or we are hoping to work on today, is the ultrasonic sensor. Some of you might be familiar with it. That's those that are already in the field, and those that are beginners or are just diving into the field would not really know about it. Although I posted some pictures on the components we'll be using in the group, I think some days back. If you've been on the group for some days, I believe you should have seen it. So we'll be using the ultrasonic sensor as the proximity sensor in this project. So basically, I would just want to explain a little about the sensor for those of us that don't have an idea about it. So if you don't have an idea, please pay attention. I want you will be a bit fast about this class because I'm very occupied. I wanted moving the class actually, but since I've promised to hold the class, I just couldn't do that. So we'll be a bit fast. So please pay attention as much as you can. I'll take questions in the group after the class. So if you have any questions along the line, please just drop them on the group, and I promise to respond to them at the end of the day. All right. So the ultrasonic sensor basically is a proximity sensor actually that is meant to detect obstacles, right? It is meant to detect if an obstruction is in front of a system or a robot, right? So basically, we have different type of proximity sensors. The ultrasonic sensor is just one of it, and it does this with the help of what? Sound waves. It does this with the help of sound waves. What happens is it sends out sound waves. The sound waves intersects or collides with obstacles or obstructions in front of the sensor and returns back to the robot or to the sensor. The sensor takes this sound waves, right, and calculates the distance, right, between the robot and that obstruction, right? So today I'll be teaching you how to connect it and how to actually write the code to give you a feedback on the distance that is being measured between the sensor and the obstacle, right? So without wasting any much time, I would like us to open our Tinkercad. I told us that we'll be using the Tinkercad online platform to do our connections since most persons reached out to me that they don't have the materials on ground. So that's a very good platform where we can all practice it. And at the end of the day, if some of us are able to get some of these materials, because subsequently we'll be having physical class, live class, where I'll be building these things and you would see it happening. But for now, this is just an introductory session, right? So for the benefit of those that don't have the materials, we'll be using the software or the online platform, right? So I believe most of us here have opened because I told us to set up the account, set up a personal or a student account. So I believe most of us here have done that. Please, if you've not done that, Can you just signify if you don't know about it, if you've not heard about Tinkercad before? So I'll guide you on how to set up an account as now, so you can set it up and we can start up. Please, do we all have our Tinkercad platform set up? All right, good. Okay, good. All right. Okay, somebody just dropped a message joining today. Okay, that's fine. But do you have you set up your Tinkercad account? That's what I just want to find out. Please, if you have, I would like to share my screen now so you actually see what is happening. Okay, Mr. Daniel, you're welcome. You're here. Nice to have you today. All right, all right, thank you. Okay, so I'll be sharing my screen now so you can actually see what is happening. Like I said, today will be a bit fast. It will be a bit fast. So I'm going to be sharing my screen so you can actually see what I'm doing. Please, if you've set up your own account, you can also log in, please. So we'll work together. While I'm doing it here, you can also follow suit over there. Okay, so I'm going to share my screen now. So Mr. Daniel, please, this is just a continuation from where we stopped yesterday, right? So just follow suit. All right, so I'll go here. This is what it is. All right, so this is basically how the platform looks, right? You have a drawing board or and you have components, right? A lot of components which you can make use of. You can select from a lot, like quite a lot of components, right? To build whatever you want to. So this is what you're going to be using. So like I said, today we are going to be focusing on the ultrasonic sensor, right? And see how it measures distance. Probably test it and see how we can use it to control the obstacle avoiding robots we plan on building today. So I'm just going to bring out the Arduino board first of all. We're going to bring out the Arduino board. Now, like I explained yesterday, in yesterday's class, the Arduino board is basically the brain of the system, right? All the codes we'll be writing are going to be sent into this board. If it was a physical or live practical, you won't actually see this wire connected to it, right? But this is a cable you use in powering this board to send in your code. When you write your code on your computer, you use this cable, USB cable, right? To power the board, you connect it to your computer and send in the code to your Arduino board, right? And in summary, please, for those of us that don't have idea and we're not in yesterday's class, in summary, this board basically has the power to send out and receive data, right? It can send out digital data and it can receive digital data. It can also send out analog data and receive analog data, right? Now, we have 6 analog pins. We have 6 analog pins from A0 to A5, as you can see here. Let me zoom this in so you can see properly. So we have 6 analog pins on the Arduino board from A0 to A5. We have about 14 digital pins from D0 to D13. We have 3 ground pins. Ground simply means the neutral voltage or the negative, right? Negative, normally in power supply you have positive, negative. So ground is your negative, right? The V in is where is another point through which you can power the board. Yesterday I explained that this board can be powered in three ways, right? There are 3 ways through which you can power the board. You can either power it from the USB port, which is what I just spoke about not long ago. You can also use this black pin you have over here. This is a DC adapter, right? This adapter you plug on the wall socket and it gives you a pin at the end, right? There's a rectifier that converts the AC to DC and you can use that to power this board, right? And you can also use a DC source like a battery to power it using the V-in pin, which is this, and a GND pin. Any of the GND pin works fine. So when you have a DC source like a battery, you can power this board. But one thing you need to consider is this board has a power rating. You don't just pick up any battery or pick up any source and just plug it in and power the board. You can end up damaging the board, right? So the board basically has a voltage rating of 7 to 12 volts, right? So anything within that range would work fine, right? So the board has a rating of 7 to 12 volts. So please, when you're working with your board physically and you want to use a power source, please make sure it falls within that rating so you don't end up damaging your board. So that's basically in summary what this board is about. Then this is called a reset pin, a reset button. When your code is actually running, you can press this reset button and it resets the whole system and it starts again, right? That's basically what reset does. The Arduino can also give out voltage. You can see 3.3 volts pin. You can see the 5-volt pin, right? And this black stuff you have here on the top is basically the chip, the processor, right? It is not actually written, it is not indicated here, but when you get to this board in real life, you will see the name of this chip. It's called an ATmega 328P chip, right?
I have a question.
What are you saying, Mr. Zain?
How to check if that Arduino is working or not? Where we have a Arduino, but I can't check this is properly working.
Okay. You have the Arduino there with you. That's fine. So I didn't get your question. What was your question?
So there is an error that it cannot shown laptop.
Okay. When you do you have the code? Sorry, Mr. Zain.
But the program can't upload.
Okay, you want to know how you
The program can't be uploaded.
Mr. Zain?
Yes, sir.
Okay, please, can you just type your question in the comment box and I will reply to you because I can't really get what you're saying. Can you just type your question in the comment box or in the chat box? Thank you. All right, so as I was saying, the digital pins, like I said, can give out digital data and also receive digital data, and similarly to the analog pins. But basically, the analog pins are by default input pins, right? They're used to receive input analog data. So please take note. So I'm going to bring out the ultrasonic sensor also. So I'll just type ultrasonic there, right? And bring this out. So this is one type of it, and this is another type, right? So I'm going to be using this, the HCSRO4, and not this, right? So I'm going to be using this. The HCSRO4 has 4 pins, please. So take note when you're bringing it out, just take note of the pins. It has 4 pins, the VCC pin, trick pin, echo pin, and the GND pin. Let me enlarge this again so you can see very well. Okay, so this is basically how the ultrasonic sensor looks like. I'm not close to my kit here. I would have physically shown you one, but subsequently we will do that because we'll be working with the materials. Okay, so this is basically what we'll be using to check for distance, check for obstructions or obstacles in front of our robot, right? So this would tell us how far it is from that obstacle, and we would, through our code, control the robot and tell it what decision to make when an obstacle is at a certain distance, right, in front of it. So I'll be teaching us how to connect to this right now. After connecting, we'll go to write the code, right? So please just take note. If you're on Tinkercad, please just follow suit as I connect, right? We don't really have much time, like I said. So I'll just bring this here, take this up. Okay, so now the ultrasonic sensor basically has a voltage rating also. All the electronic components we work with have voltage ratings. So it's very good you check for the ratings of this system, of these components before you make use of them. So you don't end up sending in a high voltage, right, or a very lesser one. So you can just go online, browse about the component, and you see details on them. Right, so the ultrasonic sensor basically can operate with a 5-volt supply, right? So I'm going to be sending a 5-volt supply to the ultrasonic sensor. Like I said earlier, the Arduino is capable of giving out 5 volts, right? So I just take out 5 volts from here, right? And I connect it to the VCC pin, right? That is that, right? So what's next? The trick pin, right? Now the trick pin is similar to the word trigger, right? When you hear trigger, right? Trigger is basically used to send out bullets in a gun, right? So the ultrasonic sensor uses the trick pin to send out these sound waves. Like I said earlier, I said the ultrasonic sensor sends out sound waves and receives them back. And through these sound waves, it calculates the distance between the robot and the obstacles. So the trick pin is uh, used to send out these sound waves, right? And we're going to be using a digital pin to send this out, because immediately the trick pin comes on, it sends out waves, and immediately it goes off, the waves stop sending, right? So we're going to be sending sorry. So I'm going to connect this to a digital pin. So I'm going to be using pin 2, right? I'm going to be using pin 2. All right, that's fine. Well, I hope we've done this though. All right, so the next pin is the echo pin. The echo pin. So the echo pin is used to receive the sound signals or the sound wave that was sent out by the trick pin, right? So basically, just like the way echo works, when you enter into an empty room, you make a sound. When you make a sound and you stop making that sound, you get to hear reflections of that sound like continuously. That's basically how the echo works, right? The echo, you get to hear it, it's a continuous kind of sound. It's a waveform sound. So due to that, we'll be making use of a pin that is capable of carrying out that functionality. And when I mean functionality, it's capable of receiving such a continuous signal. And we have such pins, those kind of specialized pins on the Arduino, on the digital section of the Arduino. If you take a look at the Arduino, you will notice that there are some pins that have a kind of coily signs in front of them. There are about 6 of them, 3, 5, 6, 9, 10, 11. They have this coily waveform sign in front of them, and that is what is indicated here, that you have digital in bracket PWM, right? That stands for pulse width modulation, right? So these are pins that are basically used to receive or give out a kind of a continuous signal, right? They have the capability of receiving a modulated signal. So for the echo pin, we'll be using a PWM pin. Please take note. So you connect your echo pin to a pulse width modulated pin. So I'm going to be using 6, right? So you can choose any pin of your choice. So the next one is your GND pin. Of course, you know GND, like I explained earlier, is your ground or your negative, right? So I'll be connecting this to the negative of my Arduino. So that's basically just it. With this, you've done your connections. Basically, in real life, if you want to connect this physically in real life, you need a power source, right? You need a power source. So let me just, for the purpose of that, so you can understand better, I'll be using a power source in this diagram. Although this diagram already has a USB port attached to it, so that when we simulate, it just fixes itself in, right? So you don't need to power the board. That powers the board automatically. But because of, I just want you guys to understand the use of DC sources, right? That's why I'm using this battery. So I just want you to understand how DC sources work. Batteries in particular, right? So the battery has basically 2 terminals, the positive and the negative. Of course, you can see the rating on it, 9 volts. And I told you the Arduino has the capability of using 7 to 12 volts, basically, for an effective output, right? So this is a 9-volt battery, and you can see it has a positive and a negative terminal. So you can connect the positive to what? To V in. When you're connecting a battery, you connect the positive to a V in pin. Then you connect the negative to the GND, right? Connect the negative to the GND pin. right? That's basically how you connect a power source, a battery in particular, right? So that's that for that. So I'll move on to writing the code now. I'll move on to writing the code now. So please, I hope we've been able to draw this. Who is having issues or challenges drawing this on his or her Tinkercad platform? So I can just guide you before we move on to the code. Have we all been able to do this?
Yes, please, we have.
Okay, that's good. All right, so I'll just move on to the code. So on the top right, at the top of your component list, you have the code, the section, the option for code, the option for start simulation, and the option for send to. As you can send it to someone, share with people and apps, right? Good. So we're going to be clicking on code, right? This is where we're going to write the code. And for the coding, we have different ways of coding this, right? The Tinkercad has different options for writing codes. You can make use of this. I explained this yesterday. This is in Scratch form. All these blocks are coded, so you don't need to start typing codes again. All you need to do is pick and fix, pick and fix. But this is not what we're going to be using, right? Because when you start working on your normal projects without the Tinkercad, you have to basically type your codes in your software, and which is what we'll be doing subsequently. We'll have to install the main software, the Arduino IDE software, right? Like I said, this is just an introductory class. That's why I'm using this platform. So subsequently, we are going to use the software. So we're going to change this from blocks to text. So change this to text, and you click on continue. And of course, you'll see some default codes already written in the code platform, right? So we're going to delete or remove this default code so we can write it again from start, and you will understand it better. All right, so just remove everything you have there except for the void setup and the void loop. Okay, I also explained something in the group when someone asked about the language, the programming language used in this training. I explained and I said that this the programming language was actually taken from C++. It's called embedded C, but it's basically from C++. So they are very similar. So if you learn how to do this, you're definitely going to find C++ a bit easy when you want to learn. And if you know how to program with C++, this is going to also be very easy for you to learn. So they work hand in hand. As you can see at the top, it is commented as a C++ code, right? So this is basically very important if you want to dive into C++ programming. Okay, so the first thing to do is to declare your variables. I explained this also yesterday. When you're writing your code, there are three sections you have to actually attend to. First is where you declare your variables. The second is the void setup, and the void setup is where you actually activate these pins or you initialize them. That's basically what you do in the void setup. You state or you tell the Arduino if the function these pins are carrying out are input functions or output functions. And how do you know that? You get to know that if the Arduino is receiving data from that device or that sensor, or it is sending out data. If it is receiving data from that device, that makes it an input. And if it is giving out data, that makes it an output. So that comes in the void setup. That's where we're going to do that declaration. Then in the void loop is basically where we write the main code. And like it says, void loop. The loop here stands for a repetition. So it keeps going like that, and it doesn't stop, right? So any code you have here in the void loop is what you have continuously running, right? That's where you write the main code. So back to the top, we are going to declare variables. And like I said in the class yesterday, variables are basically containers that are used to store data, right? So if we're assigning a container to a data, or we're assigning a variable to a container, a device, right, to a pin number, we actually have to declare that device, right? We actually have to declare it. So yesterday we made use of an LED, and I explained how to declare. If you want to declare a variable, you have to make use of a data type and a variable name. A data type comes first, followed by the variable name, followed by the data which you are assigning it to, right? So if you have let's say you have a container or a variable, right? And the variable contains numbers. If the variable contains numbers, you will send or you assign, you use a data type called integers. You use a data type called integers. If the variable contains letters, you use a data type called what? Called strings. If the variable contains if the variable contains letters, you use characters. If the variable contains letters, you use strings, and so on and so forth. Okay, I just got a notification that this meeting is about to end in 10 minutes. Okay, that was why I created two links, right? Because I'm basically using the free mode. So after when this goes off, please do well to join back using the second link so the class can continue. All right, so without wasting any much time, we are going to go straight into declaring our variables. And like I said, variables are containers that stores data. And in this case, we'll be declaring the pins of the ultrasonic sensor, right? We connected the trig and the echo pin to pin numbers. So we'll be declaring them in our declaration section. And since they are connected to pin numbers, 2 and 6, of course, are numbers, right? And they are small numbers. So we use integers to declare them. So I'm going to start by saying int trig. Trig, of course, is what I'm deciding to use as the variable name. You can decide to use anything of your choice, but it's good to use something you can actually relate to, right? So I'm using int trig is equal to 2. I used pin 2 for my trig. So assign yours to the pin number you choose. And at the end of your assignment, put a semicolon. Put a semicolon at the end. The semicolon at the end is used to terminate your code. It tells the compiler that your code stops there, right? If just like the way you have full stop in English language, after a line of sentence, you put a full stop. Similarly, that's how the semicolon works. So at the end of each line of code, you put a semicolon, right? So I'm going to declare my trig also, my echo also. Int echo is equal to, I assigned it to pin 6, right? So echo is pin 6. Now, there are two variables we are going to be requiring, right? The ultrasonic sensor measures distance, basically, and we said it does this with the help of sound waves, right? So we actually need uh, a variable or a container that should store the time it takes for the sound wave to leave the sensor, reflect on the obstacle, and come back to the sensor. We have to create a container that should store that data. And also we would create another container that should store the data of the distance. After the distance is being calculated, there should be a container that should store that distance, right? So that makes it 2. And we're going to be using the data type long to create these variables, right? And while we're using long like this, the normal long, right? Now, this long basically is used when you're assigning your variable to a larger set of whole numbers. If you're expecting a larger range of whole numbers, it is preferable to use long, right? Because long can actually hold them better. Int are just for smaller whole numbers, right? So looking at the fact that we might not know the level of distance the ultrasonic sensor might measure, let's make use of long. So long duration, or you can use long time, any one you want, because it basically wants to tell us how long it took the sound wave to leave the sensor and return back to it. So I'll be using long duration for that, and I'll be using long distance to tell me the distance between the sensor and the obstacle in front of it, right? So I'll be using long distance to tell me that. So the next thing I'm just putting a semicolon at the end without any data, because at this point we don't know what the distance and the time is, right? So it's an empty variable, more like it's a container we just created, but it's empty because we haven't actually stored any data in it. So as you can see, it wasn't assigned, just like the way trig and echo was, right? So these are empty variables. So the next thing we'll move on to is the void setup. So like I said earlier, the void setup is just used to initialize or activate these pins, right? It tells the Arduino if these pins are actually carrying out an input or an output function, right? So basically, the trig, like I explained, I said is used to send out the signals, right? So that should tell you that this pin is an input pin. So to initialize this pin, you use a function called the pin mode function. The pin mode function, and this is how it's written: pin in lowercase, M is in capital letter or in uppercase, and the rest of the word is in lowercase, right? But it's all written as one word. pin mode, right? But just M is in capital letter. I hope this is clear enough. Let me make it more bold so you can actually see the code. I hope this is clear enough, guys. Can you hear me?
Yes, please, it's clear.
All right, good, good. Okay, so let me move on. So the next thing is we have to put our arguments there, right? The details of the pin. Now, what variable are we connecting this pin to, right? You can decide to use the variable name or the pin number, right? This is an assignment operator. So when you've assigned the variable to a data, what it means is that you can actually replace this variable with the data anywhere in the code. So you can decide to write echo here. You can decide to use echo here, or you can decide to use 6. Any of them works fine. But I prefer using the variable name. Why is because of in cases where you want to make changes, right? You want to make alterations to your code. You don't need to go all through your code changing your pin. For instance, you want to change your pin from pin 6 to pin 5, right? If you have used pin numbers throughout your code, you have to go through your code changing those pin numbers. But if you're using the variable name, all you need to do is just change the pin number from here and you're good to go. So I prefer using the variable names in cases like this. So echo basically is an input because it receives the sound wave that is being sent out by the trig pin. So like I said earlier, the trig is an output because it sends out the sound wave. So I'm going to write this trig. Please, another thing you should make sure or you should ensure is that the way you declared your variable here, whatever way you declared it here should be the same way you're using it in your code. You can't use a capital E here, and when you come later in your code, you change this E to a lowercase e. It's going to give you an error. Please take note. Make sure you continue with the same pattern you used in declaring your variable. Thank you. So for the trig, like I said, trig is an output. It sends out the sound wave. Good. So one more thing we are going to be doing is to activate or initialize what we call the serial monitor. If you look below this screen, look at my mouse indicator is now, you would notice what is written there, serial monitor. Now the serial monitor basically is just used to show you an output, right? It shows you the output of what is actually happening in your code, right? So before using it, you have to activate it first. And there's a function you use in doing that. The function you use in doing that is the serial.begin function. Serial.begin, right? And in brackets, you write what we call the baud rate. You write what we call the baud rate. This baud rate, this figure you're seeing here, 9,600, is called the baud rate. And this tells you the amount of data that is being processed by the serial monitor. We have different baud rates, right? Different baud rates. We have them, a lot of them. When you're making use of the Arduino IDE and you open the serial monitor, you see a couple of baud rates you can choose from, right? So we'll be using the baud rate of 9,600 for this practical. So the next thing is to go to the void loop, right? We don't need to declare this the duration and the distance in the void setup, right? Because they are not assigned to a pin number. They are just empty variables that are there to actually hold some information we'll be working out in the void loop, right? So they would come into play in the void loop. So now the void loop, how do we go about it? The first thing we do in the void loop is to send out data, right? Now, look at what is happening. The ultrasonic sensor has to give out data before it can receive data and calculate distance. So the first thing to do is to send out data from the trig pin, right? The first thing to do is to send out data from the trig pin. How do you do that? I explained yesterday that there are 4 important functions that we all need to take note of. The digital write function, the digital read function, analog write, and analog read. Now, when the Arduino wants to send out digital data, we use the function called the digital write function. When it wants to send out the digital read function, when it wants to take in the digital signal, we use the digital read function, and it's very similar to the analog signals also. Okay, I have less than 1 minute, and I don't want to continue right now, so it won't just stop on the way, right? So let's just exit this and join through the second link so we can round this up, right? Thank you very much. Please just exit and join through with the second link. Thank you. On digital write. Now, take note of the way I'm writing this function. It's similar to the way I wrote pin mode earlier, right? Digital write. Only W is in caps here, right? The rest are all in lowercase. If you're writing this code on, you can even notice that the data types we used here actually have a different color from the variables we created, right? This is to tell you that they are keywords. If you're using the Arduino IDE to write up this code, you will notice that some of these key functions we are using changes their color to tell you that they are keywords, right? So digital write, what's the variable we want to control right now is the trick pin, right? The trick pin. And what do we want to do? We want to send out digital data. Now, I explained also yesterday, for those that were here, for digital signals basically have two states, high and low states, 1 and zeros, right? So if you want the Arduino to give out a 1 signal or a high or an on signal, you use the programming language high, right? We make use of the language high. So we're going to use high here, telling the trick pin to come on and give out data. But basically, before we do this, we have to first of all consider the initial state of the trick. Before we even go into sending out the data, the trick pin was initially off, right? Considering that the trick pin was off, let's just let the Arduino know that, okay, initially, make sure my trick pin is off. It is not sending any data. So let's just make that off. Let's just put that to be off. Make your trick pin off at the initial state. Digital write, trig, low, right? That's the off state. So the trig should be at the low state for how long? Just a very short time. Just a very short time. So I'm going to be using just 2. You can use 5. Let me use 5 for 5 milliseconds. This is a very small time. I explained also yesterday that in Arduino, when you write the 1000 units, it detects or it relates to 1 second in real time. So if I'm writing 5 here, of course, you know, it's a very short time, like 5 milliseconds, right? Like 5 milliseconds. So what's the next thing to do? You make it high. You will send out the signal, right? Turning it high, right? So how long do you want to send out this signal? You want to send out this signal for a very short time also, right? You want to send out the signal for a very short time. So how do we send out the signal? Digital write, trig, high. And for how long? The delay function. Delay function is basically telling the Arduino to keep on carrying out an activity, right, for a particular amount of time. Just like the word delay means. Delay actually tells us stay there for some time, or, you know, keep doing what you're doing, right? So it should keep sending data for 10 milliseconds, right? And after sending out that data, it should go back off, right? It should go back off. So digital write, trig, low. So I've put off back the trick pin, right? So as it stands now, the trick pin has given out data and has gone off, right? Now what is left is for us to receive that sound wave that has been sent out by the trick pin, right? That is what is left now. Okay, please confirm you can hear me again, because it seems some persons are not hearing me. Can you all hear me, please? Mr. Dan?
Yes, we are here.
Okay,
Yes,
good.
we are hear you.
Good.
Yes, we can hear you.
All right, good. So the next thing is to receive this signal we've sent out from the trick pin. And how do we do that? Right? We use a function called the pulse in function. Now I said earlier that we're creating 2 empty variables called the duration and the distance variables, right? The duration is basically meant to tell us the time, right? The Arduino takes in sending out this data and receiving data. And distance will basically tell us how far it is, right? So now we want to fill up the duration container or the duration variable. We want to get this time, right? And how do we get this time? We get this time by taking note of when the echo pin receives the data that is coming in, right? It's just like you send someone to the market and you're calculating the time the person would return. And when the person comes back, you can now say, oh, what happened? What made you take 2 hours to return? You understand? It is at that point of coming back or the return of that person that actually tells you the actual time that person has taken. So we are getting our time taking duration from the time the signal enters into the echo pin. So there's a function we call the pulse in function. We call the pulse in function, right? Just like it means literally the pulse, when the pulse enters into the pin, that's just basically what that function is saying. Pulse in function, in brackets, echo high. So when the echo becomes high, it means it has actually received the signal, right? So pulse in, echo high. That is the function we are using, right? Or the line of code we are using to get this time that is taken. Now, the next thing we are going to be getting is the distance, right? The distance of the sensor from the obstacle, right? The distance from the sensor to the obstacle. And don't forget that you're mounting this sensor on your robot. So if the sensor is saying I'm 5 meters away from or 5 centimeters away from this obstacle, it definitely means that your robot is 5 centimeters since the sensor is on your robot. So the distance, how do we get distance? If you're very good in physics, you will know that speed is equal to distance over time, right? So from there, you can actually cross multiply to get your distance, and distance is equal to speed times time. You've already gotten the time at the top there. The time at the top there is a minute, please. You've gotten your time already as duration, right? So what is left now is to get your speed. And how do you get your speed? The speed is a constant data. It is constant value. Speed has a constant value. There's what we call speed of sound wave, right? Speed of sound wave is basically 343 meter per second, right? But if you're converting this to centimeters, so it can fit into the Arduino timing, you have about 0.034, right? So you won't be using the standard meter per second value. You'll be converting it back to what? Centimeters, and you have about 0.034 343 as the case may be. 34 works, 343 works, right? And you multiply it by what? By the time. And the time, we've gotten our time to be the duration, right? The duration. Basically, now one more thing is left to do. We've gotten speed is equal, distance is equal to speed times time. But don't forget, the sound wave is actually going through is going back and forth. Like it goes out, meets the obstacle, and comes back. So it has done 2 cycles, right? It has actually carried out 2 cycles. It left the sensor, went to the obstacle, met it, and came back. So the distance between the sensor and that obstacle is the total distance divided by 2. So if we've gotten distance here, we have to divide this value we are getting here by 2 to get the actual distance. I believe this is clear enough. If it's not clear enough, please just drop me a message on the WhatsApp group. I'll explain better. So distance is divided by 2 to give you the actual distance, right? Because distance is giving us the total distance, right? Between the total distance in going to and fro, right? But dividing it by 2 would give us the actual distance between the sensor and the obstacle. So after getting distance now, what is left is what? We want to see what the distance actually is, right? That is when you're working with a serial monitor, right? Before we go into using conditional statements and using the distance to control output devices, let's just see what the distance actually is, right? So we can serial print it from the serial monitor, right? We can serial print it from the serial monitor. We've activated the serial monitor using the function serial.begin 9600. Now we want to see what the serial monitor says about the distance, right? So we're going to use a function called the serial.println function. Serial.println function, right? You can see println there stands for line, basically print line, right? But it's abbreviated to println, right? So in brackets, there are 2 things I'm going to teach you 2 ways of serial printing on the serial monitor. The first way is by serial printing an actual statement, and the second way is to serial print the variable, right? If you use what we call if we use a double quotation to serial print. For instance, I use a double quotation and I write distance is a semicolon. You can see that what I've written is highlighted in red, right? This is just trying to tell you that this is a statement. So when the serial monitor is outputting this, is outputting the actual thing I wrote in that bracket, which is distance is semicolon, or colon rather, right? So it's actually giving us the exact statement I just wrote there. That's the first way to serial print. And it is very important to do this because they see at some point you might be making use of different sensors or different components, and you might be confused if you don't serial print a statement to actually differentiate which data is which, right? So it's very good to use statements like this. So the second thing we are going to serial print is the actual variable now to tell us what the distance actually is. So I'm going to be serial printing just distance. If you notice, you will see that I wrote my distance the same way I declared it, right? Here in the statement, I use a capital D, right? That's because it's a statement. It doesn't matter. I can decide to change all to higher case. So long as it's a statement, it doesn't really affect my code, right? But when I'm serial printing the variable, I have to write it the way it was declared. So please take note of that, right? Good. So that is basically that. We are done with the code. What is left now is to simulate. If it was the Arduino software or the Arduino IDE, what we would have done was to upload the code to the Arduino board. That was what we would have done. We would have selected the port, uploaded the code to the Arduino, then read the data from the serial monitor. But in this case, on the Tinkercad platform, that will be done for us. When we click on Start Simulation, just take note of this USB port and you will see what happens. So I guess we are all done with the code. If you are not done, let me just scroll up. So basically, let me go over the code again. What we did was we initialized we stated the initial state of the trig pin, which was off. Initially, it was off, right? So let's say it was off for a very short time, right? And after it being off, we sent out the signal, the sound signal from the same trig pin for 10 milliseconds, right? So the Arduino sent out signal, and that's why we're having the code that says digital write trig high, right? This is the point where the sound wave was sent out. And after it was sent out for 10 milliseconds, the Arduino made the trig pin load, right? Turned off the trig pin. So it just sent out a little bit of signal and goes back to the off state. Then we now had to calculate the time it took for this sound wave to meet the obstacle and return back to the echo pin, right? Using this function, the pulse in function, right? Then we got the distance. Like I said earlier, distance is speed times time. The speed of sound wave is this. It is basically 343 meters per second, but when you convert it to centimeters to fit into Arduino time, you have this times the time, which is the duration that we've gotten up there. So we are just like substituting for duration, right? Divided by 2 because it went through 2 cycles, right? Then we serial printed the distance at the end of it. So I'm going to simulate this now so we can see how this basically works. So start simulation. You can see it's initializing. Okay, so it's saying my code have some errors, right? Let's see, what's the error here? Who can tell me what the error is here? My digital write my W was in lowercase, right? That's basically what happened. So sorry about that. So stop simulation. All right, so it is basically running now. So I'm going to close the code now so we see what is happening. Now, you can see when you click on your sensor, you have the possibility of changing the distance, right? You can physically just change it here. Since you can't actually have direct contact with the sensor to, put an obstacle in front of your laptop, you can't see anything outside your laptop. So you have the possibility of changing the distance here, right? So I'm going to open this so we'll see what the serial monitor is showing as I'm adjusting this. So click on serial monitor. You would just click on the serial monitor down there, right? Click on serial monitor, right? Good, and you see it reading. I believe yours should be reading like this if you've written your code properly. So when you do this, just click on the ultrasonic sensor, right? You would see that the distance is being giving you two different readings, right? Similarly, just in conversion, it's giving us 27.9 inches on one part or 70.9 cm. So whichever reading you decide to take. But the serial monitor is basically giving us the output in centimeters, right? In cm. So if you adjust this, the more you adjust this, just take note of your serial monitor. You would notice that the distance is also what? Adjusting. Right now we have 81 cm, okay, 83, like that. So you can adjust this anywhere you want, right, to get the distance you want to use, right? Right, so that's just basically how this works. Of course, you can see how the distance changes. So with this data we have gotten, or the distance we've been able to measure, you can write a set of code and use this data to control an output, right? You can use this to control an output. So basically what this is going to do on the obstacle avoiding vehicle is to be able to tell the robot or the vehicle when it should stop, when it should navigate, when it should change course. You understand? So all we need to do is use this as we would create conditional statements using the distance variable. For instance, you would tell the robot, or you would write in your code, telling your robot that when the distance is less than this amount, right, you have to stop, you have to go back, you have to turn right, you have to turn left, right? So that's basically what it's going to do. So very fast, I'm going to add an LED, right? So I will teach us how to use conditional statements. I'll teach us how to use conditional statements, right, to this. So I'm just going to bring this back up here. Now, bring up an LED, please. Bring up an LED, or bring out an LED, right? Bring out an LED, which I said LED is called a light emitting diode, right? So bring out an LED. Sorry about this. Okay, so this is called a light emitting diode, right? And bring out a resistor, right? Now, when you bring out the resistor, you will notice a dialog box, right? You notice a dialog box, then you change the resistance of the dialog box, right? Change the resistance. Let's use a resistance of 220 ohms. I explained how to do this yesterday. So use 220 ohms, right, for the resistor. Then we connect this to a digital pin. Remember, we will just want to get a high or low state for the LED, right? We just want to put it on or put it off. So we are going to connect the LED to a digital pin. So let's say I'm connecting this to, let me connect this to pin 5 on the Arduino. So you can connect this to any digital pin of your choice, right? Connect this to pin 5. Then this is the cathode pin. Cathode basically stands for negative. This is the anode pin, right? This is the anode pin. The anode pin is the positive pin, right? And that is where we've connected our resistor to. So the negative pin, or the cathode pin, goes to the ground terminal. Goes to the ground terminal, right? So that's basically how we connect it. The positive goes to the pin number and the negative goes to the ground terminal. So we've connected our LED. I guess we've all connected ours. So we can just write the code and use the distance we've gotten from the ultrasonic sensor to control the LED. Have we been able to connect the LEDs? Who is having a challenge connecting the LED, please? Okay, that's good. That's good. I can see Mr. Taymor. That's nice. That's nice. That's beautiful. I can see your job. That's a good job. That's a good job. All right.
Thank you, sir. Thank you.
Yeah, you're welcome.
Thank you, sir.
You're welcome. I hope we are all able to get this, like the way Mr. Taymor is. Sakina, are you with us?
Yes, yes,
Okay, hope you're following.
Yes, I am.
All right, that's good. That's good. Mr. Daniel, hope you're good.
Yes, please, I'm good.
Okay, good. Sakina,
Yes.
okay, Fatso. Okay, so sorry about my pronunciation. I might not be too, All right, that's good. T-boy, I hope you're okay too. Mr.
No
Zain,
problem.
Mr. Zain. All right,
Yes, yes.
all right.
All right.
Hope you're good.
Yes, we are good.
All right, that's good. That's good. Fine. So let's just add up to the code. Let's just add up to the code. All right. So now we've been able to get distance. What is left? We just need to control the LED. We just need to tell the LED when to come on and when to go off, right? So we're going to be using what we call conditional statements, right? In programming, there are some functions we call conditional functions, right? We use them to actually create conditions. What conditions basically mean something has to happen, like there should be something to trigger up something. You understand? Like things don't just happen the way it is meant to happen. It shouldn't just happen like that. There should be a cause, right? Before that thing happens. And that's what we are going to be doing. So we're going to use the if condition. It is written in lowercase. If, you just write if in lowercase and you open a bracket. After the conditional function, you write the conditional statement, or you write the condition itself. Now, which variable are you using as a condition? We are using the distance variable. So if distance, now depending on what you want, do you want the distance to be more than a particular level before something happens? Or do you want it to be lesser than a particular level? Depending on what you want, we have different operators that will carry out different functions. We have a greater than operator, we have a lesser than operator, we have an equal to operator, right? Or an assignment operator or a comparative operator. Now, when you have two equal to, you are now trying to compare it to a particular, it has to be that exact level, right? Before that particular function is executed or that particular task is executed. But in this case, I just want to use a greater than sign, right? That's telling me that my distance should be greater than a particular level for something to happen. So let's say I want my distance to be greater than 30, right? I want my distance to be greater than 30 centimeters before my LED comes on. So when my distance is greater than 30, I'm going to write a code to put on my LED. And how do I do that? I send out digital signal to my LED, right? How do I send out digital signal? I use the function, the digital write function. Digital write, in brackets, I write my LED there. Okay, sorry about that. We've not declared. Oh, sorry about that. I thought we had. Please, before we even include the use of LEDs in the code, we need to first of all declare them, just like the way we did for trigger and echo. We need to first of all declare the LEDs. Please don't forget, right? If you want to include anything to your code, possibly a device, a sensor, whatever, you have to declare them. You have to declare them and initialize them in this void setup before making use of them, right? Good. So we're going to declare them, or declare the LED here, right? Declare it here. Int LED. I'm going to use the name LED, right? You can use whatever you want to use, so long as you know it's referring to the LED, right? So int LED, I'm connecting my LED to pin 5, or I've connected it to pin 5. So I'm declaring it and assigning it to pin 5, right? Now, my void setup, what do? I initialize the pin mode, right? So pin mode, LED. Of course, what function is the LED pin carrying out? Is it an input or an output function? It's an output function, of course, because the Arduino is sending out data to the LED, right? Telling it to turn on or turn off, as the case may be. So I'm saying LED is an output, right? The LED is an output. That's basically what is there, and that is that for that. So we now go down to the void loop to continue from where we left off. So from here, I'm not going to tell the LED to come on, right? Once the LED notes, or the Arduino receives a distance that is above 30 centimeters, it should turn on the LED, right? So the LED should come on. And like I said earlier, the LED, we are trying to achieve a digital output. So we are making use of the high function, high or low function, right? So the LED would come on. And after writing this, you close the curly brace. That's very important. After your conditional statement, you write the executable code in a curly brace, right? These are just like baskets. When you open the basket, you put in your content, you close it, right? So the curly braces basically hold the executable code. So after your if condition or after your conditional statement, you open a curly brace and write your code, right? And close the curly brace. I've had cases where students do mistake this, and instead of using a curly brace, they also end this line with a semicolon, which some is reasonable though, because most people are already used to ending every line. But just take note that when you're having conditional statements like this, you write the executable code because there's a particular something will actually happen before that code works, right? So that is not embedded to the code generally, right? So it doesn't run until this condition is met. Thank you. So after this, we now do what? We go to the else condition. So the else basically works with the if, right? So it's just like saying if this doesn't happen, the alternative should happen, right? If this doesn't happen, the other thing should happen. That's basically what it's telling us. Now, if and else is when we have basically two expected outputs, right? When we have two expected outputs, for instance, the possibilities are just two. If this is not this, then any other thing, right? But when we are having more than two expectations, for instance, we have about three, four, we'll employ the use of what we call the else if. The else if, right? Now, subsequently, we are going to be using that too. So you would see how it works. I hope we just have more time so we can actually use that. But for now, let's just use the if and the else function. So else, I want my LED to turn off. I want my LED to turn off. So similarly, I'll just write my code. Digital write LED low, right? Digital write LED low. That's just basically what it is. So I've now told it that when my distance is less than 30, that is just basically what the else is doing there, right? If it's saying if it is greater than 30, now for the else, I don't need to write any condition again, right? I don't need to write any condition because the code understands that when you say else, you're actually meaning that whatever is outside this condition you've told me in your if, that is what would happen before I turn off or I put off your LED. So definitely you are saying if it is less than 30. So anything from 29 down to 0 would actually give you a low state for your LED, right? So I'm going to close the curly brace for my else also, right? I'm going to close the curly brace. So if you check here, if you notice here, you'll see that we have two curly braces at the end of this code. We have two curly braces at the end of this code. The first one closes the else curly brace, and the last one is for the void loop. Please, when you're writing your code, I just have 10 minutes. I hope we finish this up before the time runs out. When you're writing your code, you have to make sure and ensure that the last curly brace you are closing is that of your void loop. The void loop curly brace should be the last one you close. If it was the Arduino IDE, when you click on this, it will actually tell you which curly brace you have closed. When you click on these curly braces, it tells you the one it's working with, right? But the Tinkercad platform does not give us that functionality. So that's by the way. All right, so that's basically how to embed the LED or how to control it, right? So I'm going to simulate this now. So we'll see how it works. So I'll just click on start simulation. Oh, sorry, I'm having some errors in my code. Let me see. Let me cancel this. Okay, LED output. Okay, sorry about that. I think I've closed this twice. Okay. Okay, let's see this again. All right, good. You can see that's another problem with the Tinkercad platform, right? It just because I declared the LED before the trick, it just had to, show an error. So it wanted the LED to come last. You can see as I changed the position, everything worked fine, which is not the same to the Arduino, right? When you're using the Arduino IDE, you can actually, the arrangement doesn't actually matter. You can arrange it, right? The way anyone can come first. The LED can come first, followed by the ultrasonic sensor, right? So when we start working with it, I believe you will see all these things I'm talking about. So I'm going to simulate this now. Close the code. Of course, you can see my LED is on. Why is this on? Because my distance is more than 30. I'm having a distance of 69.3 cm. So the LED would actually be off. Okay, let me take this down to less than, okay, this is now 27. What happened to my LED? My LED is now off, right? My LED is now off. You take this above 29. Okay, let me bring this down so we can actually get a clear view. All right, so if you bring this down, just take note of what is happening. Just look at the distance. As the distance drops, all right, immediately it drops from 30, right? Immediately it drops from 30, you already have an off state, right? So that is basically how it works, right? So you can see how the ultrasonic sensor can basically control an output, right? How the ultrasonic sensor can control an output. You can also see this from the serial monitor, right? It's the same thing. You can just click on the serial monitor and see what is happening, right? And sorry, you can also decide to serial print the LED function, right? You can decide to serial print the LED function. You can decide to serial print my LED is high. For instance, let me just explain what I mean. Okay, so in your code, you can decide to add a serial print here, a serial print statement saying that your LED is high. For instance, serial.println, serial.println, you can just say LED is on, right? This just makes your code, just looks nice, right? Nothing more, nothing less. It doesn't change the way the whole system runs. Okay, so that's basically it. So start simulation. So now what you see in the serial monitor is a statement that follows suit that your LED is on. Sorry, here should be LED is off rather. Here should be LED is off. Okay. So of course you can see it. LED is on because it is on. And when it comes below 30, you have LED is off and distance is this. Gives you the distance and tells you that your LED is off. Okay, so that's basically what is happening. Please, have we been able to do this? Who is having difficulty doing this before my time runs out so I can just guide you? Please, were we all able to do this? Were we able to achieve this?
Okay, sir, thanks so much. I think mine, I have a problem with the serial print.
All right. Can you share your screen very fast? Because I have a very short time. Can you just share your screen so I'll see what you've done and correct you? Yeah, very fast, please. Please share your screen. Okay.
Okay, I'm doing it.
All right. Okay. Okay. So you're having all right, scroll to the top from the start of your code. Let's see what you've done. Go to the beginning of your code. Scroll your code to the top. Okay, that's fine. All right. Okay, carefully scroll down. Okay, keep scrolling. Okay, click on start simulation. Let's see what happens. Click on start simulation. Wow.
In this
Oh, you're using I. Oh, sorry. Your print line is. Are you using I there? Not. It's not I. It's print LN.
L.
Yes.
Oh,
Print,
I think
yeah.
I
Print
think
line.
that's where my problem is because
Yeah.
I was doing it as I.
Yeah. No. It's called print line. Print line. But the line is abbreviated as LN. So you can simulate now and confirm. Simulate now and confirm.
Perfect.
Okay. Good. So try and control that. You can close the coding area. Close the coding area so you can actually see what is happening. Okay. All right. Good. Click on it. Okay. Good. All right. That's fine. That's fine. Okay. Why that is happening is called, okay. Good. There's a level you can go, right? When you go below that level, the ultrasonic sensor does not measure distance at all. Good. So that is basically that. Please, is there any other person having an issue with
Thanks
this?
so much, sir.
Yeah, you're welcome, Daniel. You're welcome. Please, is there any other person having a problem with this? Okay, okay. All right, that's good. That means we are all good, right? I think my time is up. So basically I would guide everyone on what to do, right? I would send probably a video. I would make a video on how to connect some other parts of the components because of time. Like I said, I was busy. As I was in this meeting, I've received a series of calls that I've ignored, right? Because I've been busy. There are some other things I needed to attend to. But since I fixed this class, I could not just shut it down, right? So please just bear with me. Probably we might fix another class, maybe tomorrow or some other day to compensate for this and finish up the whole thing, right? But please just bear with me today, right? And practice this, just practice this. You can lay hands on that. Like I said, I might also do a video, drop it in the group so you can that will guide you in what to do, and probably build the system before we even have the next class, right? So thank you very much. I really appreciate those of you that were able to make it, right? See you.
Thank you, sir. Thank you.
Thank you.
You're welcome. I hope the class was clear enough and we understand.
It was clear and we understood.
Yeah.
Okay, thank you very much. Thank you very much. So see you in the next class. You can just drop your reaction and drop your messages in the group. I will attend to them. Thank you very much. Bye.
Thank you. Bye.
Bye bye.
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 Bye.